Now today we will see various IoT protocols. As we discuss about the IoT architecture, in that we saw the four layers of your what IoT architecture. In that the very basic layer was your link layer, then network layer, transport layer and application layer. So the various protocols used in the link layer are Ethernet, WiMAX, Wi-Fi, WiPAN, wireless personal area network, or the mobile networks like your 2G, 3G, or 4G likewise. So these are the various link layer protocols that can be used in your IoT application. So with the help of these protocols, the connectivity is going to be established with various IoT devices. So they are basically used for your establishing the network between various IoT devices. So how these IoT devices are going to be connected with each other with the help of either V4, with the help of your either V6 or with the help of your 6 low pan. What is this 6 low pan? That we will see in upcoming lectures. There is one separate topic on your 6 low pan that we will be discussing later on. So these are your what network layer protocols: IPv6, IPv4, 6 low pan. These are your network layer protocols. You all are aware about IPv4, IPv6. We will see 6 low pan later on. Then the next layer is your transport layer of your IoT architecture. So in that transport layer, two basic protocols are going to be used: your TCP and UDP. I hope you all are aware about TCP and UDP. The full form of TCP is Transmission Control Protocol, whereas the UDP is your User Datagram Protocol. The main difference between TCP and UDP is TCP is your connectionless or connection oriented. UDP is your TCP is your what we can say reliable. That means whether your packets are delivered or not, that is going to be acknowledgement is going to be received in your these protocols. So these are your what transport layer protocols, TCP and UDP. The basic difference between TCP and UDP you all are aware about. You saw the differences, the protocol stack, the header structure, everything related with your TCP and UDP. You already gone through your CNT subject. Then the next layer is your application layer protocol. In application layer protocol, various protocols, in application layer, various protocols used are your HTTP, Hypertext Transfer Protocol, COAP, WebSocket, MQTT, XMPP. These are various protocols that are going to be used in your application layer protocol. So every layer will have various protocols, and the functionality of those protocols are depend on the type of IoT application. Which type of IoT application you are going to develop, the protocol is going to be used for that particular IoT application. So these are it is not like that for every application all these protocols are going to be used. These protocols are used according to the type of or nature of your IoT application. Please remember this. Then we will see the logical design of your IoT. That is, we are going to see the functional block. In previous lecture, we saw the physical design. Now we will see the logical design. Logical design of an IoT system refers to an abstract representation of the entities. It is not the in-depth active entities. It is just an abstract representation of any of the entity, and not only the entities and the processes without going into the low level specification of the implementation. Means what? यहाँ पे क्या होता है कि हम सिर्फ abstract entities और processes क्या है वो देखेंगे, उनके डिटेल में नहीं देखने वाले, या फिर उनके लो लेवल तक जाके कैसे वो एंटिटी क्रिएट की है, कैसे वो प्रोसेस डिफाइन की है, दैट वी आर नॉट गोइंग टू सी इन दिस लॉजिकल डिजाइन. An IoT system comprises of number of functional blocks that provide the system the capabilities for. What the IoT system will have? It will have various numbers of blocks. And what that blocks will going to do? They are having the capabilities for identification, sensing, actuating, communicating and managing the various IoT devices or various IoT applications. So this is the functional block diagram. So here you can see it will have various devices, various IoT devices will be here. Those IoT devices will communicate. They are going to use some services. Along with this, there is one parallel activity, that means everything should be properly managed. Means what? There should be the proper communication between all the IoT device. It should not like that की एका वेळी एकच डेटा जो आहे तो ट्रान्समिट होणार आहे आणि दुसऱ्या डिव्हाइसचा डेटा जो आहे तो क्यू मध्ये वेटिंग. नो, इट शुड नॉट लाईक दॅट. All the data should be properly managed. There should be the proper management. There should be the proper connection between various nodes, and the security is going to be established. That security will be at different layers. Like there should be the security for your data security should be there. There should be the network security. There should be the hardware security. असंच तुम्ही कुठे पण हार्डवेअर माउंट करून नाही देणार, त्याची सिक्युरिटी तुम्हाला प्रॉपरली बघावी लागेल. You need to focus on the data security. That means when the data is going to be transmit from one device to another device, that data should not be hacked. So there should be proper what? Data security. There should be the network security. That means if you are going to use your wireless network, then there should not be the chances of hacking that wireless network. So the proper security measures should be implemented in each and every IoT application. Whereas the topmost layer will be your, it will have various IoT application. So one IoT application will going to use various services. One IoT application will going to focus on the data network and all the types of security. That IoT application will going to manage each and everything very properly from effective communication purpose, and all those four activities will going to take place on various IoT devices. That's why it is named as your functional block diagram. If you remember what is the functional block diagram, functional block diagram will not going to focus on low level activity. म्हणजे कोण एक्झॅक्टली कोणत्या टाईपच्या सर्व्हिसेस इथे फोकस केलं नाही, किंवा कोणत्या टाईपची सिक्युरिटी मेथड इम्प्लिमेंट केलेली इथे फोकस नाही केलेला आहे. ओनली फक्त त्यांनी काय केलेलं आहे, दे आर गोइंग टू फोकस ऑन, you need to implement the security, you need to properly manage the things, there should be the proper communication. How the communication takes place will be different task. What kind of security you are going to implement, that is different task. What kind of services IoT application will going to use is a different task. It is just an overview of your what IoT application. So this is, that's why it is named as your functional block diagram or logical design of your IoT device or IoT application. Then here we saw there should be the communication between various devices. The device can be various IoT devices, or the communication should take place between the devices of your IoT application. So how this communication will take place? To execute the proper communication between various devices, there are some communication models. Like the first one is your request response model, second one is your publish subscribe model, third one is your push pull model, and the last one is your exclusive pair model. So we are going to see all these models one by one in your upcoming slides. So remember this, these models are going to focus on the proper communication between various devices of of your IoT application. Whatever IoT application you are going to design, that IoT application will have various IoT devices. Like there will be one Raspberry Pi, there are various sensors, there is one actuator, there will be proper power supplies given. So how the communication will going to take place between your Raspberry Pi and sensor? How the communication should take place between your Raspberry Pi and actuator, like this. So this kind of thing is going to be focused using these communication models. So the name itself suggests that the communication model will going to focus on the communication. Then what type of communication, or the communication between whom? The communication between IoT devices, not the communication between IoT application. दोन IoT application मध्ये communication establish नाही होणार आहे. The communication will be established in one IoT application. एकाच IoT application मध्ये असेल, पण त्या IoT application मध्ये असलेल्या सगळ्या devices मध्ये कसं communication establish होईल, that will be focused by these communication models. So first one is, the name itself suggests that this type of model will work on your request and response. आपण हे डिटेल मध्ये पुढे बघणारच आहोत. The second model will focus on the publish and subscribe activity, whereas the third model will work on push and pull activities, whereas the fourth model will be related with your exclusive pair. What type of the model they are, that we will see one by one. So let us see the first model, your request response model. So if you remember, or if you are aware about the request and response, when we discuss about request and response, definitely there will be the client and server, because the client will going to send the request to server. Once that request is received from client to the server will going to process that request. It will going to check what type of resources required by the server. They are going to search the resources at third level. Then they are going to prepare for the responses. When he started using the various resources, like the resource can be your suppose printer, database, or scanner, there can be the different resources. So server will going to use the resources. On the basis of the resource, they start preparing the response, and that response is going to be sent to the client from the server. That's why this type of model is your request response model, and this request response model is established between your client and server. So in case of your IoT application, the client will be your different sensors. For your local IoT application, and for local IoT application, your server will be your, let's say it will be your Raspberry Pi, because all the sensors and actuator will going to send the data to your Raspberry Pi. The Raspberry Pi or Arduino or any of the IoT device will going to process that data, and on the basis of that processing, either it will respond to the actuator, or it will going to send the data to the server, actual physical servers. So the request and response model will be basically related with your clients and server. Client will send the request, server will receive that request. On the basis of that request, the server will start going to process that request. If needed, it will start accessing the resources. On the basis of that, the response will created, and the response is going to be sent to the client as per its request. The second model is your publish subscribe model. Here the publish subscribe model, what happens in case of your publish subscribe model? In case of your publish subscribe model, there is one publisher, there is one broker, and there will be various consumers. So publisher will going to send some messages as a topic. The message is published to topic 1. This message is going to be sent to various topics. At the broker end, the broker will going to send that topic 1 to consumer 1 and consumer 2. The topic 2 will be sent to the subscriber of consumer 3. That means the broker will have various subscriber. If you can see, the broker will have various subscriber, and that message is going to be sent to various subscriber from the publisher. That's why it is named as your publish subscribe model. The broker will have various subscribers like this. इथे हा एक सबस्क्रायबर दिसतोय तुम्हाला, हा दुसरा दिसतोय, अजून तिसरा असेल, चौथा असेल, पाचवा असेल, like this. But there will only be one publisher, and that publisher will going to send the message to all the subscribers, and all those subscribers will send its message to all the consumers like this. So इथे या सबस्क्रायबर कडे किती कंझ्युमर्स आहे? कंझ्युमर 1 and 2, म्हणून त्याने तो मेसेज कुठे सेंड केला? कंझ्युमर 1 and 2 ला. या सबस्क्रायबर कडे कोणता कंझ्युमर आहे? कंझ्युमर 3. That's why that message is sent to consumer 3 by this second subscriber, which is received from the publisher. So this is what your publish subscribe model. In terms of your publish subscribe model, there is only your what? Publisher and subscriber will be there, and subscriber will send it to the consumer. The next model is your push pull model. When you are talking about push and pull, there will be the queue. Remember this. The publisher will going to send the message to the consumer through queue. If I wish to send the message to consumer 1, I want to send the 4 messages, let's say. Then what will happen? The 4 messages will be sent to the your what? Your consumer through the queue, like this. This will be the first, second, third. Likewise, all the messages will going to be sent to the, just a minute. Yes, the publisher will going to send whatever message he wishes to send to the consumer. The message will be sent to the consumer through queue. And you know the nature of queue. The queue is like your first in, first out. Whichever first message will be in the queue, that first message will be out to the consumer, like this. The messages pushed to the queue and the messages are going to be pulled from the queue. That's why it is named as your push pull method. And you know the nature of queue, that is your first in, first out. It is not your stack like your first in, last out, or last in, first out. And the next model, the last model of your communication model will be your exclusive pair model. In this, there will only be one client and there will only be one server. What will happen? Only one what we can say activity will be performed at one time. Like you can see here, the client will going to request for connection setup. Then server will going to send the response of accepting its request of connection establishment. Then client will going to send the message to the server. Server will going to process that request. Server will prepare the response, and that response is sent to the client from the server. As this client receives the response from the server, what server will do or what client will do? Now the work of client has been finished. Now client will send the request for closing the connection and server will going to close the connection. Here you can see why it is named as your exclusive pair, because there are only two entities. That means there is a pair of entities, client and server. There are no resources. There is no other queue, like nothing like your broker, subscriber, consumer. Nothing will be there. There will only be a pair of device like your client and server, and only one activity will going to perform at one time. If you observe the arrow will only be your unidirectional arrow. That means only this activity will perform at this time, then only this activity, then only this, and like this. That's why it is your exclusive and pair of devices. That's why it is your exclusive pair model.